Hey Pinksters, welcome to the course. I think you have already done the previous course that is regarding prompt engineering, and in this course we will be acquiring some in-depth knowledge regarding prompt engineering. So without wasting much time, let's jump directly to the content. The first and the most important thing of the OpenAI nowadays is embeddings. The concept of embeddings is changing the whole world, so we must know about the embeddings first. So what are embeddings actually? So in GPT-3, word embeddings refer to a technique used to represent words as numerical vectors in a high dimensional space. So each word in the model's vocabulary is assigned a unique vector, and these vectors capture the semantic relationships between words based on their usage in text. So let's try to visualize this thing, what is going on actually. From this slide, I think you'll be able to understand the embeddings clearly. So in here, assume that we want to find the text similarity between two texts. In the first stage, we are taking the data as an input, and then by using the OpenAI embeddings model, we can change this data into a vector representation. So why we are transforming this thing to a vector representation? This vector representation is nothing but some numerical values. So we are transforming the text data into a numerical values just to find the similarity between the two vectors. It will be easier for the LLMs to find the similarity between two objects if we can transform this text or any other objects into a vector form. That's why we are transforming the text to vectors. Whenever this vector representation is done, then it will be possible to find the similarity between two vectors by using the cosine similarity formula. We'll be talking about this cosine similarity in a brief, but just to know that the vector representation or the numerical value is used to find the similarity between two objects. Then this vector representation form, these vector forms need to be stored somewhere so that you can find, so that you can work with that later on whenever you are required. For this thing, you need storage, that is vector database. You can use this vector database to store your vector representation or the numerical value. So now there are so many vector databases that are available online. Some examples are Pincecone or Subbase. So you can use those to store your vectorized form values. So this is the main concept of the embeddings. So now I think you have understood why do we need embeddings. So why the embeddings are so much important, because it will help us to convert the data into numerical values. And by using these numerical values, it will be pretty easier to compare two datasets or two objects or texts to find a similarity or difference between the two objects. And the formula that we use to find the similarity between two objects is called cosine similarity. So let's move to the cosine similarity. So cosine similarity is a widely used metric to measure the similarity between two vectors in high dimensional spaces, such as embeddings. So embeddings are numerical vector representations of objects such as words, sentences, or even documents. So you have already known this thing. And then they can be generated using various techniques like word-to-vec, GLOVE, or BERT. These are some models that can be used to generate the vector representation of the objects. In the context of embedding, cosine similarity is particularly useful for finding similarities between words, phrases, or documents by comparing their respective vector representations. And this helps in various NLP tasks such as documents retrieval, sentiment analysis, and text classification. So these are some use cases you can remember. So what is the formula for cosine similarity? This is the formula you can see here. Assume that you are comparing the similarity between two objects. One is A and the next one is B. So the cosine similarity between the two objects should be calculated by using the dot product of A and B. And then again we'll calculate the magnitudes of the vectors A and B, and we'll divide this thing. Here you can see it is written also here that A and B are the two vectors being compared, and then A dot B is the dot product of A and B are the magnitudes of vectors A and B respectively. So we'll be using the dot products and the magnitudes to calculate the cosine similarity between two objects. We don't need to use this formula, or we don't need to write this thing somewhere, but just for your curiosity, I am mentioning it here that this formula is used to calculate the similarity between the two objects. So this is the algorithm that is used to find the similarity between two objects. So there are some other algorithms that can be used for the finding the similarity, like cosine similarity, checkered similarity, or even more advanced methods such as pre-trained language models like BART or universal sentence encoder. By using the different models, you can compare the similarity scores for each pair to get a sense of how well the chosen method can identify the relatedness between two texts. But normally, as far as I know, in case of OpenAI, the cosine similarity algorithm is used in the models. So now I think it is clear to you that how this similarity is calculated between the vectors. And then if we move to the use cases of the embeddings, you need to mention some use cases. Here you can see the use case of embeddings. So OpenAI embeddings offer a range of practical use cases due to their ability to understand and generate human-like text. So here are some examples we'll be talking about. That is, you can see the use case that natural language processing. In case of natural language processing, we can use this thing. So GPT-3 uses embeddings to process natural language inputs, which allows it to understand the meaning of words in a given context. This is useful for tasks such as language translation, sentiment analysis, and text classification. So in these three cases, we can use these embeddings. And then the recommendation systems, for the use of recommendation also, you can see it can create some movies recommendation based on their descriptions or reviews. These embeddings can be used to recommend similar items to users based on their preferences. So in case of recommendation also, these embeddings can be used. And then the next use case is text generation. The embeddings can help to generate natural language text. By encoding words as vectors, the model can generate coherent and contextually appropriate sentences and paragraphs. And then the image captioning, GPT-3 can generate embeddings for images, which can be used to caption images in natural language. By understanding the visual features of an image and the semantics of the text, the model can generate captions that accurately describe the content of the image. So that is a very powerful use case that humans are trying for a long time to capture the actual content from an image. So, and to do this accurately, these embeddings can help you. Then question answering, that GPT-3 can use embeddings to match questions with relevant answers by encoding the questions as a vector and comparing it with the vectors of potential answers. The model can identify the most appropriate response. So in case of question answering also, you can use this embedding. So there are far more applications. If we move to the OpenAI documentations, then we'll be able to see. Here you can see we are now in the OpenAI documentations, and from the guides section you need to move to embeddings, and then you can see here what are embeddings. OpenAI's text embeddings measure the relatedness of text strings. So embeddings are commonly used for the search, clustering, recommendations, anomaly detection, and diversity measurement and classification. So there are some use cases you can see here. So here you can see an embedding is a vector of floating point numbers. So the distance between two vectors measures their relatedness. So small distances suggest high relatedness and large distances suggest low relatedness. You can see how to get embeddings. To get the embeddings, send your text string to the Embeddings API endpoint along with the choice of embedding model. You can see here they have used the text embedding ADA002. So this is the latest model. We'll be also using this text embedding ADA002. Here you can see some use cases, and this is the vector representation of the embeddings. The embedding will transform the text like this. This text is now transformed in a numerical value. This is a list of numerical values. You can see this embedding. That this embedding is created just for this line, that is your text string goes here. And then if you want some Python code examples, and you can go to OpenAI cookbook, and here they have mentioned some OpenAI embedding models, that is text embedding ARA 002 and DaVinci 001, Babbage 001, Curie 001. So you can use either one, but we'll be using the text embedding ADA 002. This is a revolutionary one, and this have an output vector dimensions of 1536. That means it will be created a 1536 dimensions vector. This is magical, so you can easily understand the power. And there are some use cases they have mentioned, that data visualization, this is used for data visualization in 2D, embedding as a text feature encoder for ML algorithms, then classification using the embedding features, zero shot classification, obtaining user and product embeddings for cold start recommendation, clustering, text search using embeddings, then code search using embeddings, recommendation using embeddings. So if you go inside this, then you will be able to see the use cases of this. They have showed you some practical examples, so you can use this thing. So we'll be looking at some of those, and we'll be trying to figure out some of those practically. We'll be trying to find out the similarity between the texts. Let's forget the theory and go for the practical things.